This is the Logan Squared class. This is your final review before Wednesday's test. This is Tuesday, May 1st, 2018. These are the questions from the test. These are variations of questions you weren't sure how to do or you're a little uncertain of it. So the first question is a true-false question, and it says 0.075% of $5 is the same thing as 0.75%. Oh, sorry, I had this wrong. The variation would be this, 0.75%. That's what it should be. So the question you have to identify is whether or not these two numbers are the same. So the first thing you should do is whenever you have a percentage like this with a fraction in it, so anything like this, my advice to you is to first change that to a decimal. So 3/4 is really the same thing as 0.75. So therefore, this is the same thing as this. And once I examine this and compare it to this, we see that we're dealing with two different numbers altogether. This is significantly less than 1%, and this is 3/4 of 1%. So they aren't the same thing. So the first thing you need to do is in questions of true-false, if you're asked to compare something like this with this, simply convert the percent part that's in front of it to a decimal, and you'll be able to see it clear. The second question asks you to find 0.02% of $680. So this is a calculator question, and you're allowed to use a calculator, but you don't necessarily have to if you didn't want to. You could do it a different way. But with a calculator, what you should do is first, because it's a percent, it's always out of 100, and 0.02% is 2/100ths of a percent. Another way I could write that would be 2/100ths of a percent. But this is not the same thing as 2%. Right? Those are not equal. 2/100ths of a percent is a much smaller number than 2%. It's actually, if I was to draw it, I'll just do a new page here. If I was to draw it using these, if this was 100 squares, and I was to clone this, let's bring it over here, 2/100ths of a percent would look something like this. And then I'd have to zoom in here to this, and that's what it would look like, right? 2/100ths of a percent would be much less than 1%, and in fact, it's only 2/100ths of a percent. So going back to that question, what is 2/100ths of $680? Well, I can't use this. This is unusable. But if I change it to an equivalent fraction, I would have 2 out of 10,000, which is 2 10,000ths, which is tenths, hundredths, thousandths, 10,000ths. So therefore, if I was to interpret the whole thing, this is 0.02% of 680. I then ask my calculator to do the thinking for me. I go 0.0002 times the $680, and it tells me it's approximately 14 cents. Right, approximately 14 cents. I'd round up to the nearest cent. Okay, that was the last one we just did. In the next question, you're asked to find 125 and 1/10% of 2,000. So the first thing you need to do is understand the magnitude or the size of the number. Your answer, you can expect, will be more than $1,000, or $2,000, excuse me, because you're having more than 100% of it. So if your answer turns out to be less than $2,000, you did something wrong. So when you have a percent with a fraction in it, you need to change that to something more readable. Since a tenth is really decimal 1, these two are the same thing. Then I want to think of percentages as being out of 100. So this is really 125.1 out of 100, which is 1,251 out of 1,000, because I'm going to create an equivalent fraction. And once you have that, you can change it to an equivalent mixed fraction, which is 1 and 251 thousandths. And that's important because once you have it as a mixed fraction with a base 10 denominator, 1 and 251 thousandths represents 100%, 25%, and 1/10%. Of the $2,000, use your calculator, 125.1% of $2,000 is $2,502. Okay? That would be the answer. So it seems reasonable because before I did it, I knew that I was going to have to do that. Oh, actually, you know what? This is a mental math question. That's how you do it with a calculator. This is supposed to be mental math. Let's go back in time. Back in time. Back in time. Back in time. Oh, not that far back in time. Back and forth. There we go. This is a mental math question, I think. So for this one, I want to think of 125% as being 100%, 25%, and a tenth of a percent. If I add all those together, I would get this number here. Okay? So 100% is $2,000. 25% is half of half, since half is $1,000 or 50%. Half of that would be $500. And for a tenth of a percent, the new learning in grade 8 is you take your decimal, moving it one, oh, that's not the line. Move it once, you get 10%. Move it twice, you get 1%. Move it 3 times, you get a tenth of a percent. In this case, $2. You add them all together, you get $2,502. That's how you do it mentally. I think that was a mental math one. Anyway, whatever. You now know how to do it both ways. The next question is, no, it's not. The next question is a calculator question for sure. And you know it is because usually I make these numbers a little bit more complex. So 3 3/4% would be the same thing as 3.75%, a quarter of a percent less than 4%. That would be 3.75 out of 100 since it's a percentage, which is 375 over, anybody? 10,000. Because you have to multiply it by 100, 2 places to get rid of it. And you multiply 100 by 100, you get 10,000. So tenths, hundredths, thousandths, 10,000ths. 375 10,000ths looks like that. Multiplied by your dollar amount. Taking my calculator. 3.75% of 2,805. No, yeah, decimal 20 is approximately, since I'm rounding, $105.20. Okay, $105.20. Your next one asks you to interpret this both as a fraction, a decimal, and as a percent. So I know that all of this shaded in would be 100% because there's 100 parts there. So, or one object shaded in. So as a fraction, or as a percent first, we're going to do percent. We have 1, 2, 3, 4, 5, 6, 6.5%. Because this here is not a full percent, it's only a half. So 6.5% or 6.5%. As a fraction, it's this. As a better fraction, it's this. And as a lowest term fraction, 13 over 200. Bad fraction, good fraction, lowest term fraction, all originating from this percentage. Of those 3 that I circled, this one here will be the one I use to interpret it as a decimal. It's 65 thousandths, tenths, hundredths, thousandths. So in green, this picture represents this is a fraction, this is a decimal, and this is a percent. And your last question, I think it's your second last question. 3 1/10%. So when given this picture, it asks you, what does 3 1/10% look like, shading it in. So what I would think people would do to get it wrong, they would do this. Now I'll maximize my highlighter, make it nice and big here. Here's what I would think a wrong answer would be. 1, 2, 3, and 1/10. So that would be actually not 3 1/10%. That would be 310% because this would be 100%. This would be 200%. This would be 300%, and an additional 10%. So 310%. So with that said, what I would expect you to do is shade in 3 of them. That's 3%, and then a little line here, and then a little magnifying glass, and that little square will have 10 parts. 1/10 shaded in, that would be 3 and 1/10%. Okay, so that would be all you'd have to do for that picture there. Okay. And your last question is your composite or your multi-taxed or multi-percentaged amount. The reason why we use these questions is there is such a thing as discounts and taxes together, but actually before you guys were really around, you guys were pretty young when this happened, the government changed over from having 2 taxes to having 1 tax. Now we have an HST, which stands for Harmonized Sales Tax. And before that, we used to have 2 taxes. We used to have a PST, which is a provincial sales tax, and a GST, which is your government sales tax. So back then, it was important that you could do 1 tax and then get the other tax, but now we don't have that. So the only variation we really need for this is to find a discount and then a tax on top of it. So the $880 TV is going to be given an 8.5% discount. So there are 2 ways to do this, as I explained before. If this is the 8.5% discount, and this whole thing represents $880, and if they're going to take off 8.5%, that means I only have to pay for 91.5% of the item. If I'm going to be given 8.5% discount, I'm only paying for 91.5%. So the 2 ways you can do this. 91.5% of the TV, which is, I can't remember, $880. The sale price should be $805.20. And that's going to the calculator once. That's calculating 91.5%. However, if I calculated 8.5% of the $880 TV, I would find out that it's a $74.80 discount. I would then take my TV, subtract it's $74.80, and I would get the same price as I did before by calculating 91.5%. So it's up to you which way you do it. If you want to calculate the discount and then subtract it from the price to get the sale price, you can do that. If you want to draw a picture like this, which I recommend you do because it's great for your cognitive development, then you could do it that way. Now, once you know the sales price, then you have to draw a second picture if you wanted and say this is 100% of the item, and this is the additional 14.4% for tax. So if this is $805.20 plus the tax, that would be your final price. Now another way to do that, instead of finding the 14.4%, let's do that first. So 14.4% of 805.20 is, so your tax will be $115.95. Add that on to your price of your TV, and your final price will be, in red, $921.15 approximately. However, what the book wants you to be able to do is instead of calculating 14.4 cents and adding it on to 100, simply calculate 114.4%, which would be the cost of the TV and the tax together. Okay? So if I take that sale price, sorry, that's the wrong button. If I take 100 and 14.4%, that's represented by 1.144. That's 114.4% of the sale price. Your final price will be the same thing, but you only have to go to the calculator once. Either way is acceptable. Either calculate the tax and then add it onto your sale price, or just go to the calculator once by doing over 100%. Either way is fine. Okay? Any questions for that before I press the stop button?